Welcome everyone to another presentation up to the time. Today we are going to be looking at the building drawing CXC 2021 examination. So without any further ado, let's get into this. Okay. So today we are going to be doing this entire exam, and I'm also going to be going through this exam carefully. So the first thing, I'm going to read all the instructions. I'm going to highlight keywords, and I'm going to explain the specifications. Some of these specifications will be explained via sketch, while others will be explained using images found on the internet. Okay, so let's see what we have here. Caribbean Examinations Council, Caribbean Secondary Education Certificate Exam. So this is your technical drawing exam for building. Option A, paper 2, technical proficiency. And this exam lasts for 2 hours and 40 minutes. So what does each candidate need for this exam? Well, each candidate should have the following for this exam: traditional drawing method, 2 sheets of drawing paper, both sides may be used, drawing instruments, drawing board and T-square, metric scale rule. Now, we are going to be adhering to option B, which is the computer aid drafted method. A minimum of 3 sheets of 11 by 17 paper, personal computer with monitor, keyboard, mouse, and printer, computer-aided drafting software. Note: after completing each question, save your work electronically on the available storage device. At the conclusion of the exam, the invigilator will give you instructions for submitting the save file. All right. All dimensions are given in millimeters unless otherwise stated. When first angle or third angle is not specified, the choice of projection is left to the candidate's discretion, in which case the type of projection used must be clearly stated. Where scales to be employed are not stated, the full size should be applied. Each candidate should use his/her own judgment to supply any dimensions or detail not directly shown on the drawings. The number of each question answered must be written next to the solution. Each candidate must enter his/her school code and registration number in the appropriate space at the bottom right-hand corner of each page. You are advised to take some time to read through the paper and plan your answers. Do not turn this page until you are told to do so. So let's turn the page and see what's on the next page. This exam consists of 2 questions. So there's 2 questions we're working with, divided into 2 sections. There's a section 1, which is working drawing, and section 2, which is sketch and design. Answer both questions. So you have to answer the entire exam, right? I like it this way so that there isn't any confusion. Students know that they're answering question 1 and question 2. That's it. Candidates may use either traditional drawing method or the computer-aided drafting method. We are going to be using the computer-aided drafting method, which is AutoCAD. Section 1, drawing, working drawing. Do not spend more than 2 hours on this section. Figure 1 on the enclosed sheet. We will look at figure 1 after we've read these instructions. So figure 1 on the enclosed sheet shows the outline of a building and the proposed site for a single-story residence, right? That's what figure 1 shows. Draw the site plan to a scale of 1 to 100. So this is an interesting piece of information we need to underline. It's a site plan and it's drawn to a scale 1 to 100, showing the location of the building. What else do we need to have on this site plan? We need to have show and label the boundary lines. So I'm going to Yeah, show and label the boundary lines. We also need proposed building in accordance with given setback. We need that. Sewer pipes in relation to proposed building. We need that. Septic tank and soak away pit. Direction of flow for drainage of surface water. An eve line. A north symbol, very important to determine where north is and where the compass points are. And we need to identify the streets by giving them the name. We need to label the driveway and draw a driveway. Also, we need to show dimensions for setback. So these are some important labels that need to go on the drawing for us to get our 40 marks. So we need to draw these and then we need to label these and we get our 40 marks there. So let me just clear this drawing quickly. And let's look what else is needed on this drawing because I didn't capture everything. We need boundary lines. And we also need to print a suitable title and scale use. So the scale use is going to be here. And the title use is going to be here, which is called a site plan. So the T represents the title and the S represents the scale. So that takes care of item D. Okay. So let's clear that. Now let's go on to what it says down here. Note, standard drawing practices and conventions for producing working drawings are to be followed. All right. Now, they give us specifications for this site plan. Very important. This is something that needs to be outlined or underlined. Specifications. This tells us our setback from the front and our setback from the side. And if you realize there's a difference between the setback from the front is greater than the setback from the side. All right. So now let's look at the image. This is the image that was given to us. This is all the information that we were given. And we have to use this information to solve the question. So what do we see here? The first thing we see here, the site, outline of the proposed site. So this is the site here. And when we say the site, this is the land. So these are our, what I would consider our boundary indicators. And these are the boundary pegs there. So this is the site within here. This is the north arrow here, which tells us the direction of north. And then these are our measurements, our information. This tells us, so how do we read this set of information that I've just circled? Interesting. This relates to the measurements, and this relates to the angle. Right? That's how we read those. And with the combination of knowing how to insert the measurements and the angle, we are able to get this shape. All right. Now, before we go any further, let's go back over the instructions. And okay, I didn't describe what this drawing here is. This is the building. This is the building that is going to be placed onto the site. So let me roughly draw out the building. Oops. So that is the building is going to be placed here onto the site. This is not exactly the shape of the building, but that is what my smart pen gave me when I drew it. So I'm going to clear this now. And let us go back to the instructions because the instructions have some things that I want to explain. Okay. So we are here now. Let's go through these carefully. Let's look at this one. Boundary lines. What is meant by boundary lines? So boundary lines, here we have a person standing and then there's a white line in front of them. So they're standing on a grass and there's a white line which is separating them from this grass over here and that grass over here. So that's what a boundary line is. The boundary line actually sets out where the end of your property is. So you would know this is your property. So this is the site, and over here is not site. So you can't build over here, not site. All right. That is basically the purpose of a boundary line, so that you can get a mental frame of your property, where your property is, where it starts and where it finishes, so that you wouldn't build on another person's property. Okay. So that's boundary line explained. Let's go down the line and let's look at proposed building in accordance with given setbacks. So the first thing is we need to understand what are setbacks. What is meant by the term setbacks? All right. So for this now, I'm going to bring out a diagram here that I've created. This diagram has a drawing of the entire project. But why I brought this out is because I want to go through what the setbacks are. So let's look here. Let's look carefully to this area here. And let's see what it says about a setback. So these are the setback lines here. So just see, imagine we know what the boundary is. So I'm going to draw the boundary in red. Yeah. So that's our boundary. So that's my land parcel. Now I want to build on this land, but before I build, I need to know where I can build, because I can't build all on that land parcel. There are certain areas that you can build and certain areas you can't build. Now the setback determines the areas that which you can build in. So these are my setbacks here now. I'm putting them in purple, and this is the square. This setback, this square that I've just created, or rectangle, it's probably a rectangle. That is the area that I can build in. So I can build within this frame. I can't build on the outside of the frame, but the outside of the frame is still my land. So what happens on the outside of this frame? I can place trees. I can place trees there. I can do other things. I can plant, but I just can't build. So always remember that the setback determines where you can build on the project. So this is the project here, and if we were to look at the setbacks is somewhere up here, there, and there. Those are the setbacks there from the project. All right. So I think I've explained what setbacks are. So, and boundary lines. So let's go down and see what else needs to be explained. Sewer pipes in relation to proposed buildings. So what are sewer pipes? Sewer pipes are the pipes that are used to transport the waste from the home to the manhole and then to the septic tank. All right. So what do these pipes look like? Let's have a look here. These are what these pipes look like here. And they are usually planted, or they're usually placed underground, so that they will affect, so that when you look at the landscape, you don't see these pipes. So these pipes come from the home. You dig a hole, you put them underground, and then you connect them to the sewer system that you're installing around the home. So sometimes people connect these to manholes, and then from a manhole to a septic tank, or some people connect them to the actual sewer that goes on to the public main. But whatever you do, you have to use pipes. So now, in relation to proposed building, that's the next part of the question that we need to consider. How does this work out? So let's look here at our image of the drawing, and this is what the project will look like. So let me first, this is the proposed building here. Proposed building, and then now These are our sewer pipes here. These dash lines that you see here, these are our pipes. And these pipes go straight to the septic tank. Out of the kitchen, they go to a grease trap. Out of the bathroom, they go to something called a manhole, which is a temporary chamber, and then they go off to the septic tank. Why do you represent them as dash lines? Because they are underground. And once they're underground, they're not seen. And pipes or lines or anything that isn't seen on the drawing is represented as a dash line to represent, it's not seen with the naked eye, but it's there under the surface. Okay? So that is how we would install the sewer pipes in relation to the proposed building. You can see the proposed building and you can see the sewer pipes and how they're connected. And we understand what the sewer pipes do. They get rid of waste. So let's look here, a septic tank and a soakaway. And all of these are connected. So this whole item is connected. That is connected. The sewer pipes in relation to proposed building, the septic tank and the soakaway are what the pipes are connected to. They are either connected to a septic tank or a soakaway. So let's have a look here at what a septic tank looks like and what a soakaway looks like. I don't have, yes, I have a septic tank here. And these are the septic tanks. And you could just imagine that somewhere in the building, a pipe is going underground here and it's connected to here. Yeah. And then this one is also connected to here. Yeah. So this is a septic tank which stores all your waste. And why do we see these round holes here? What these are the openings. So what happens is when there's too much waste in here, you would call in the septic tank truck, which is right here, and the long holes will connect to here, and they will extract the waste through these pipes, and they will put the waste into their truck, and then they will take the waste and dump it or treat it. So that's why you have these openings on the septic tank to extract waste when it builds up, and you can take it away in the truck and the truck treats the waste. Okay. The soakaway. What is the soakaway now? Let's look at that quickly. Soakaway is an area where the pipe, which takes rainwater or surface water, which is settled on the roof. So you get a pipe discharging the surface water, like right here, that settles on your roof. And then you have a hole in your ground where all the water settles. So whereas you're creating a pool here, there's all your rainwater will settle in here. So what you can do is that you can put plants in here, you can grow things, and all that would always have water. Once the rain falls, the water will be channeled right here to this spot. Or you can also slope your land so that the surface water that's on your land settles here at this spot. And then this spot, because there's water there, you can plant stuff and it would flourish. So that's what a surface, that's what a soakaway looks like. And that's the purpose of a soakaway. Let's continue now. Direction of flow for drainage of surface water. What does that really mean? That when the surface water, when the rain falls onto the surface, we need to get the surface water off of the surface so that it wouldn't create pools of water so that people can access the property. So we need to create a drainage. So what does this drainage look like? This is what you will see. Some people would have this style drain. So essentially, the water will flow in this direction, the water will flow in that direction, and it will flow into the drain here, right? As you can see the water marks. onto this drain, the water droplets, and that is how we will get the surface water from around our property off. So you would just channel the water into these drains, and that's what it looks like. All right. And these are obviously the pavers, which you're able to step on. You step in pavers, and then there's a drain, which is embedded into the stepping pavers. So that takes care of that. Now, let's go down the line. When we hear eave line, what do we think of, and where would we find the eave line? So if we look at a building, this is where the eave line would be. This part of the building is called the eave. So this is where the roof ends. And this material right here is called the fascia board that I'm shading over. That's called the fascia board. But the general area, or what all of this is called, the eave. Okay? So that is the eave of the building. If you ever heard of the eave, that's what it looks like. This is good for sheltering. So if you're outside your home, or if you're outside a building and the rain is falling, what you need to do is you need to get under the eave if you want any shelter. If you can't access inside the building, but you need to shelter from the rain, you can actually put yourself under the eave, and the eave will provide a little bit of shelter. It wouldn't fully shelter you depending on how the rain is falling and the direction of the rain. Okay, north arrow. I think everybody knows what a north symbol looks like, or north, or better known as a north arrow. This is it here. And the north arrow goes on all drawings to identify where north is, so we can orient ourselves. Right. Identify street names. Simple. Wherever the streets are, they have a name. And the streets here have a name. This one is called Horsham. And then this one here is called Richmond. So these are the two names. You need to just place these names onto your drawing after you've drawn the streets, and you will get your marks. Let's go back. Driveway. The driveway is the area which the car is parked, or the path leading to the garage is called the driveway. So just let's have a look at some driveways and see what we have here. This is a driveway. The path leading to the garage, and this is where the garage would be. All right. So this is the driveway. It's differentiated from the grass. It's in a different material. Let's look at another example of a driveway. Yep. This one doesn't lead to any garage. You just come in and you can park your car here. And the material is different. It's differentiated from the grass. Yep, that's another example of a driveway. Okay, now I think I've gone through everything here on this, whereas I have explained what these terms mean. Now, the next thing I'm going to do is analyze the question, and let's come up with a strategy as to how we are going to tackle this question. So again, let me read the question. And what does it say here? It says, draw the site plan to a scale of 1 to 100 showing the location of the building. So what we need to do is we need to put the building onto this site. This is the site here, and this is the building. We need to bring the building and put it onto the site. And once we have done that, we then need to go back and insert the features that they have told us, like the boundary line, the sewer pipe, the eave line, the north arrow, the street name, the driveway, etc., etc. We need to do that. So first thing, how do we go about doing this? Let me bring out this sheet here. And this will start us with a strategy as to how to go about doing it. So what's the first thing that I need to draw? So we are at the strategy now. The first thing I need to draw is I need to draw the boundary. Yeah, so I need to draw this boundary. And all the measurements are given. That's the first thing I need to draw. Draw that boundary. Then what's the next thing I need to draw? The next thing I need to draw is I need to draw the house. So that's the second thing. So that's the first thing. That's the second thing. Oh, sure. I have one, the vanishing pen. Let me redraw this. That's the second thing. Put a 2 there. This is the first thing. Put a 1 there. So the property is the first thing. The second thing is the actual outline of the property, of the building. Sorry. That's the second thing. Now, this building is placed onto the site. It isn't placed at a specific location. That's the good thing. So you have some flexibility as to determine where you want to place this building. Also, we know we need to put a driveway in. So that could be the third thing. The third thing is how do we access the property? This is the driveway. We can then put that in as the third thing to draw. And then what else are we going to be drawing after that? Well, let me use a different color. Let's use blue. We can then draw the sewage disposal systems. This is a set tank. This is a manhole, M for manhole. And then this one over here is a grease trap. This takes the grease from the kitchen. So we can then put in these. And that will go as my fourth thing to put in. Then, what else do I need to put in? Something that I should have put in early out before you even place the house are my setbacks. These are the setbacks here. This is setback from, it says here, setback line. And that's the front setback right there. And then there are the setbacks at the side. So I should have put these in. And then there's a setback at the back also. So just grab that line. And that's the setback there. So when setbacks are in, and setback on Richmond Street. So I would say that can be, that could either be after one, that could be the second thing to put in. Because you don't want to put in the house, and then the house is outside of your setback. So you should put in your setbacks before you put in your home. Or we are in an AutoCAD program, we can just move the house. Simple as that, right? But let me just put a number here. So seeing that I didn't insert this the first, second, or third, I'm just going to continue the sequence. So this would be my fifth thing to insert, right? So my fourth. Which are the source systems, and then this would be my fifth. So that's the fifth thing that would be inserted. Now, after that, what else are we going to insert? Well, we can then start thinking of the surface water drainage. And we're draining them to the soakaway. So then the soakaway then goes to 6. Some vegetation around the property could be 7. And I think we get a drift as to how this is going. So before this gets too confusing right now, I think it's time for me to start drawing. Now, it is time to draw. It is time to go into AutoCAD. So how are we going to do this? I'm going to insert the image here by going to insert at the top menu, strip. And then I go to attach. And now let's get in this one. That's 86 degrees. I'm really concerned for this one. That's 86 degrees. 31064 tab, 86 degrees. So what I'm doing is I'm putting these together. I didn't expect that I would have to do that. Good thing about this is that three sides are 90 degrees, which are right angles, and one side is 86 degrees. So once you put in the 86 degrees, you can put in the rest because they're just 90-degree angles. Here is a radius of 3,000. So let's put that in now and get that finished with F to fill it. Then go into radius, R for radius mode, then type in 3,000. And you can snap that, it's there, and that's your line in. So that now lets us know that our line is already being set up. I'm going to just select the line and put it into outline. Right? And also what I'm going to do is I'm going to change the line style so as it will represent line. Dash dot is what I'm going to use. I'm going to change the properties 25 to 50. Let's say 100. Let's see how that looks. I think we can use 100. And then match all the rest. So that's my line there. Also, I'm going to put some small circles around it to show the boundaries. And put circles at 200. All right, copy these around. Great. So those are the boundaries. That's my line. Now, the next thing I'm going to do is create the house. Sorry, not the house, the property, the building. Let's start with this. This is 87. So hit alpha line. I'm going to do it here. Going up 8700. Go across. Okay. This comes across 10 500. All right. And then we want something that goes up 3,000. Then that goes up. Okay. Put that to there. Offset 400. Oh, or 4,000. Sorry. Set 4,000. Good. DA. Then offset 3,000. And trim this up now. This is my building. Right? That's my building. I'm gonna put this into outline as well. So to make this bigger. Seeing that the whole thing is actually bigger, that we can all see. So this is my building, that there is my site. Now I'm going to hatch this building, hatch this, nice, nice hatch. Okay. 2000, good. Now looks good, put it into the hatch. All right, cool. Now, let us now look at the setbacks. So let us go back here and let's see the setbacks. And the front setback is 3,500. The side setback is 2,400. So what do we do with this information? This is the front. How do we know this is the front of the property? Well, we can always look at the size of the road, right? The front road is always larger than the side road. So this is larger than this side road here, right? So because the front road is larger, this is the front of the property. This will be the side. All right, that's one way we can determine the front from the side. So the front here, this is where our 3,500 line is going to come around here. And then our 24 is going to come around here. It's going to go around. It's going to go around there. And then these ones are going to go around there from 24. All right. So what I could do is to put the front one in red. That's the front setback, and the rest are in blue, are the sides. So let's clear this and put this in. So I'm here. All right, offset 3500. 3500. And then we offset this. Good, voila. Let me just stretch this out. Cool. Then offset again 2400 on all three sides. Just stretch these out. Good. Now I'm going to put these into a different layer. I'm going to put these into hidden by layer. And that's what they look like. So those are my setback lines in, so I can build anywhere within here now. So let's just grab the house and move it. I'll probably put my house somewhere around here. I just insert it randomly there. Once it's within the building area, I can place the house. So what else do I need to observe before I move on? So I've put in my setbacks, so I can tick these. Setbacks are in, very good. What else do I need to insert? I've put in the building, put in the setbacks. Now, the next thing I said I was going to do is put in the driveway. Driveway. What's the size of the driveway? Now, if this road here is 8,000 wide, and that means that's both sides. That's from one side of the road to the next side. If we split that in half, that's about 4,000. 4,000. So let's say our driveway, let's put it at about 4,000. So just draw down a line here. And then I'm going to offset 4,000. That's my driveway. And then I'm also going to break this line. Yep, because I want to fill it. And I want to use back the same radius that they had there at the beginning, which is a radius of 3,000. So I've used back that radius. And this is my driveway. So you enter, you park your car there. Probably we can actually send back this driveway all the way to there. You get more driveway. Right? That's your full driveway there. No problem. That's already in. Now, what else do we need to insert? I need to put in, so I can also go back to this as my reference, and we can tick off what I have here. The driveway is in, the house is in, the boundaries are in, and the property lines are in. What I need to put in now are the sewage systems. Manhole, septic tank, and grease trap. All right. So I know a bathroom is in this area, so let's put a point where my bathrooms are so that I would, let me turn on my point style. I can't see that. Okay, that's a point there. That's for the bathroom. Let's put one for the kitchen. Somewhere on this surface. That's for the kitchen. So now, how are we going to set up these grease traps? The kitchen, one is a grease trap, and then that goes to the septic tank. The manhole comes up, and then that goes to the septic tank. REC for rectangle, creating small rectangles. All right. So this from the kitchen comes here. You just bring it off the house slightly. Then that goes to there. That pipe goes to there. Then from there to there. Again, we're gonna make these all dash lines. So put them in hidden, and I'm going to put these rectangles as dash also. Okay, good. Let's put some labels onto them. So for this one, that's ST. If you're having trouble sizing letters, I advise to scale them. That doesn't seem to work. Let's go in here. Let's change that to 70. Drop from here, name. Then you can increase the. That's a good size there. Septic tank. I'm going to copy this around now. And this would then go to grease trap. And that then with my hole. GT grease trap. And MH, my hole. We just need to scale down slightly. Good. So those are in. Those sewage systems are in. What's the next thing? We can then just come down the line and see what needs to go in. So we can use this as a tick list. Boundary, proposed building, the current setback, sewer pipes in relation to proposed building, septic tank, and soakaway pit. We need to draw a soakaway pit. So that's what we're going to draw, and then we're going to direct the drainage water to the soakaway pit. All right. So the last time I had my soakaway pit, I can have my soakaway pit over on this side. Right? Let's see what I did with the last drawing. I had my soakaway pit on the left-hand side because I had the majority of the building centered on the property, and I had it oriented different. So I'm going to create my soakaway pit over here. And now I'm going to use SPL for this so I can create some wobbly lines. So this is just me attempting to create a soakaway pit. And a nice little formation there. All right. So I'm going to call that a soakaway pit. It doesn't have to be shapely. My soakaway might be a bit too large for some people. So just reducing the size. All right, cool. That looks good. Now my surface water, I'm going to use arrows to show where I want to lead my surface water. Surface water drain. Drainage, right? D. Let's do this. Yeah. Let's want these annotation styles down here. That's good. Change just to 200. 200. Good. Let me change my RLA to 300. Good. So that means I can code this to here. Yep. And code that. And copy this around now. You can see how I'm draining it to this direction here, generally. So that takes care of my surface water drainage. You can see where the soakaway is. And let's go now. Occasionally, I'm going to encourage everyone to save their work. Save your work. Control S is the command to save. Okay, direction of flow of drainage of surface water. I've placed that. And my eve line. Now I need to establish my eve line by just labeling it, and my north arrow by labeling, identify the streets and the driveway. Okay. So this is my eve line here. So I'm going to grab one of these, or I can grab this annotation down here, which is all good to go. I can just place that here. And that would be my eve line. E-A-V-E, eve line. Eve line. And I'm going to increase this. You know what? Just leave it there and max drop. Max drop, exclude that. Good. Great. No, what else do I need to, no, I need to also label my driveway. Yes, 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 yes. That's here, call that driveway. Driveway, and I'm going to put that at size 300. Justify middle center NC close, and that should be it. Yep, put that into the text layer. Okay, so my driveway is labeled, everything is labeled so far. Nope, I need to label my boundary line. So now I'm labeling, I can just put in these labels here. And what that is, that's my setback. So edit this, change this to boundary line. Yeah. And then we call that setback line. Yeah. Boundary line, setback line. Great. You know, we could call this front setback. Front setback. Just call this now side setback. Side setback. Give this a little rotate. You know, do the same thing with this one also. All right, bring that closer so that everything reads properly. Now, what else do we need to put into this drawing? The north arrow. The north arrow, and then the streets. So let's go here to insert. I have the north arrow here, ready to go. Just put in the north arrow, just like that. My north arrow is in. Now let's put in the streets now. You see that this street is 8,000 wide, and this street is 5,000 wide. Offset 8,000 from this line here. And offset 5,000 from this line here. Zero, connect the two of these like that. And those the streets don't connect like that. But that's just temporary. Street continues. The street continues. That means in the street continues. Mm-hmm. This is center line of the road here. No, this is not the center of this road. This is the full road. Need to remove that. Remove that. Yes. And more than likely, if this is the road here, this also would be somebody's property, and the road will open up like that, right? That's all. That's all. Now, center line, let's center this one, 2500, which is half of 5,000. Center line, max drop that, represent the center, this is center of the road there, and we can just, yeah. So now I can just trim off my setbacks. I'm just cleaning up the drawing. I'm going to put the north arrow on to this side where there's a lot of text. Now I'm going to name these roads now. These roads are called. And this one is Horsham. Horsham Street. Horsham Street. Change that to size 300. All right. Then this next street is called Richmond Street. RICHMOND, Richmond Street. 300. We're gonna rotate this one so that it says Richmond like that, just like how we see on the drawing. Place that there. Now place that also into the text layer. Great. Great, great, great. What else do we need to put onto this? I'm gonna hatch this one. Individually. Okay, no problem. I'm just going to show that water settles there. Good, that's a settle. The water settles. All right, I think that looks good so far. Let's go back to the question and see what else is missing. I got my driveway, identify the streets now for the eve line. I think I have everything here, but before, let's go through a checklist. Let's go over everything. At this stage, we go over everything. Let's drag this down here. Okay. Let me save. And let me just tick off this, because once I tick this off, then we are going to go quickly into the second question. So let's go. Boundary lines. Do I have my boundary lines? Yes. Are they labeled? Yes. Boundary lines are labeled. Proposed building according to setback. Yes, the building is there and it's within the building area. Sewer pipes in relation to proposed building. All my sewer pipes are in. Yes, yes, and they're in. Septic tank and soak away pit. Yes, septic tank is in, and the soak away pit is in. Direction of flow for drainage of surface water. Yes, that is in. Right there, right there. Eve line in. Yes, I have identified the eve line. North symbol. Yes, yes. Identified street. Richmond Street is in. Horsham Street is in. Driveway, yes, yes. The only thing I'm going to do is hatch the driveway. The setbacks are in. Yes, the setbacks and the boundary lines are in. Now, what needs to be done? I need to print a suitable title and scale for this drawing, and then it's finished. So let's clear all that. I'm going to take this opportunity now to just hatch the driveway. Give the driveway a different material. Okay. So now what I'm going to do is just change this material. Go to hatch pattern and see what's a good material. You know what? I like that earth material. Not much. People use the earth. Where is it? Oh, right here. Yeah. But that's about 2000. Yeah, 2000. Yeah. Brings it to about 45 degrees. Great. Great. That's my driveway pattern there. And now all that is left for me to do is to insert my title. So I go here, insert, and I already have a title, which is right here, which I normally use. So I'm going to explode this so I can alter it. And this one is called site plan. Site plan. Scale that they want us to use is scale 1 to 100. Scale. Now I'm going to grab the two of these and scale this up so that it can actually read properly. Yeah, I think this is big enough. Put it right there. Okay. So I've increased the some sizes of some text, and so far so good. Let me put this into a different layer. No, landscape is good. Landscape is good. Put this outline in outline. Remove this. Yeah. Cool. We need to label this as proposed building, so I'm going to put text in here. So that there is proposed building, right? So proposed building. Right. Perfect. Great. So everything is labeled. Now, what I'm going to do is I'm going to put this into a nice little frame. If we can place that in there, move out these annotation examples. All right. Good, good, good. Now, let us move on to the second question now. We got the second question, section 2, sketch and design. Do not spend more than 30 minutes on this section. All right. So they want us to sketch an orthographic sectional detail of a closed eave. Clearly label the following components: wall, rafters, lofts, fascia board, and hurricane strap. Now, first thing, we need to understand what is a closed eave. Yeah. Now, this is interesting because CXC is what they've done here is quite interesting in that if you know, you know, if you don't know, you really don't know. They've used back this word eve here, whereas they ask you to identify the eve in question 1. So if you didn't know where the eve is in question 1, it's highly unlikely that you'll be able to draw a closed eve detail, right? So again, let us just go back here to our drawing and let us locate the eve. This is the eve here. Now, it's interesting that this drawing here that I have shows an eve, but it's not a closed eve. What's the difference between this eave and what a closed eave is supposed to look like? A closed eave has all of this is closed off. So you wouldn't be able to see the soffit in there slanted. If anything, the soffit would be perpendicular to this wall. So it will be closed, all closed off. You wouldn't be able to look up there and you wouldn't be able to see those rafters. So that's the difference between this eave and what we are supposed to create. We are supposed to create a closed eave. So we are going to seal this part here. All right. Now, let's just clear this drawing, close off, and let us go. So what do we need to add to this? What does this eave need? There are some components here that we need to understand. We need to understand what a wall is. So this is a wall. Yep. Simple wall. These are walls. These vertical uprights are walls. So our detail is going to be attached right here at the top of the wall. But we are not going to be using a timber wall. We're going to be using a concrete wall. All right. They didn't specify either timber or concrete, but I'm going to use a concrete wall. What are rafters? So we have done walls. What are rafters now? Let's have a look here and see if we first understand what a rafter is. Do you know what a rafter is? These are rafters. These members are rafters. They're made out of timber. Let's also look at another example of rafters. These are rafters again, made out of timber. And they're usually set at an angle between 20 and 35 degrees. This is where the angle is taken here. So that's the angle in there. And these are the rafters. Right? And then, right. So I think this drawing explains a lot. Let's move on. What else do we need? We need something called laughs. What are laughs? These are laughs here, pieces of timber, but we're just looking at them in isolation, so this doesn't really help us to understand how, where a laugh goes and what it does. Laughs can also be under a different name. Laughs go by the name of laughs or purlins or battens. So let's look and see. These are the laughs here, and they are placed right here onto the rafters. So this is the rafter, and this is the laugh now. Right? So those are the laughs. What do the laughs do? The laughs actually receive the permaclad sheeting, which is the final material in the roof system. So we understand what purlins and what laughs are. Fascia board. Do we know what's a fascia board? Do we have a fascia board in here? Yes, we have a fascia board, and this is the fascia board right here. So the last board that will take all of the elements from the roof. So the fascia board is essentially a rafter that actually takes on all of the heat, all of the rain, and all of the wind. This is the fascia board here. Yeah, there is the fascia board. It's the board that is facing the elements, if you want to remember it, like that. Hurricane straps. Hurricane straps. No. Hurricane straps here. What these hurricane straps do, they actually secure the rafters. So this is the rafter here. And then this is the wall plate. Right? They secure the rafters to the wall plate to the actual beam. Okay? So let's look at this chart now a little carefully because a lot can be lost here. These are the screws that go into the wall and they go into the concrete blocks. These are the screws that go into the timber also, and these go into rafters. And then there are probably some screws here that go into the wall plate. So this is a strap that secures the rafter to the wall plate and also to the wall, to the concrete wall. It's called a hurricane strap. This stops movement so that when you get any high winds or hurricane winds, your structure is secured. So I think I've explained all of these terms and I'm showing visuals for the walls, the rafters, the lafts, the fascia board, and the hurricane strap. Now it is time for us to start drawing. They don't give us any measurements at all. So this is going to be a rough sketch. So prepare yourself. So they can explain it here. Here is the close eave detail to the right. You put my annotation. All right. Now let's look here and see what we have here. We have a wall that is 150 thickness with a 10 mil plaster on each side. So this is 10 mil plaster in here. And that is 10 millimeter plaster out here on both sides. So we're going to insert that. The wall plate here, we have a wall plate of 50 by 100, the piece of timber. We have our rafters here. And these are our rafters. That's the span of the rafter there, or we should say the width. And all of that is coming in at 50 by 150 for the rafters. Now let's look at the lafts. The lafts are right here. And these lafts slash battens slash purlins, they come in at 25 by 50. And the fascia board is right here. And that comes in at 25 by 200. This is the fascia board here, the strip. All right. Now, what else do we need? Oh, yeah, the hurricane straps. Hurricane straps are right here. And that is installed last. So let's clear the drawing. And let us go to work. And I'm going to offset my 10 mil on each side, my plaster. Trim. So that's my wall. Now, what I'm going to do is I'm going to put in my wall plate. My wall plate is 50, offset 50 up. Offset 100 across. Trim. Yep. Put in the X there to represent the wall plate. So that's my wall plate in. Now what I'm going to do is I'm going to put in my roof. Start my roof at this point here. And then I'm going to be using a 30-degree pitch. So I pull this line out, 741, hit tab, 30 degrees, enter, okay. So it went in 30 degrees on the opposite side. No problem. I'm going to select that, mirror, MI to mirror. Then I'm just going to send it to the other side. Erase source object, yes, because I want it on that other side. Now what I'm going to do is I'm going to offset this 150. That's the thickness. And I'm going to give my overhang, which is the distance of my eave, I'm going to give it about 300. I'm going to come here. I'll set that 300. That means I can extend these lines down here. Good. And then I will trim accordingly. So now by me offsetting that 300, this basically tells this is where my fascia board is going to be. So I'm going to insert the fascia board. Same thing now. The thickness is 25. And it goes down 200. So I'm just going to come down here 50. Square that off, trim. Right, and then I'm going to offset from that 50, 200 up. Okay, well, okay. Let's see how this is going to work out. I'm going to code that to the, yep. So I get the same size, just that I altered where the 200 starts from where it finishes. Cool. Now, I'm going to insert the close eve by just closing this off like that. And give that a thickness, still use the same 25 mil. That's there, that's in, that looks good. Let's trim now. Trim. Cool. What I'm going to do now, I'm going to insert my tongue and groove boards. Tongue and groove boards, which go above the rafters, 25 mil thick. And then the last are another 25 mil thick. So all those there. You know what? This fascia board might actually extend up. So the fascia board might get adjusted later on. Leave that there now. Let us now put in the tongue and groove boards. So I'm going to put that there, perpendicular, and each board is about 150 by 25 mil thick. So we already put in the 25, let's put off the 150. So I'm going to offset that, right? 150. Right? That gives enough to give you an understanding of what's going on there. I'm not going to get into all the detail of the tongue and groove boards. I'm just going to call them up and leave them very blank. All right. Offset this now. These laughs are 25 by 50. So offset 25 each side. Put an X between them. Yep. And then I'm going to, now we're going to copy that. Copy. Copy every other. Right. Laughs are in. Tongue and groove boards are in. Rafters are in. Close eve is in. The fascia board is in. Now, let's put on the roof material now. So I'm just going to offset 10. Offset 50 here. Good. Trim. That's how I've ended my roof. You see? That's how I end the roof. Probably that 50 is too generous, so I'm going to offset 25. Right, and then bring this line from there to here. And then just trim. All right. Now, I think that's it. Now, what I need to do to get my full marks, I need to label, and I need to show materiality, and I need to show some dimensions. So what am I going to do? I'm going to grab one of these annotations, probably the smallest size, but this will be good for me, and I'm going to bring it up here. And I'm going to insert annotations. Probably even this size is too big. Put that at size 100, and let's go from there. So the first thing is this is a plaster wall. Plaster wall. And that is 10 mil. All right. That up further. and pull that on the inside now. This now is block work. Block wall, 150 mil. Good. This is a fascia board. Fascia board. They don't tell us how much this, but what I can put there is 200 mil thick. Right? And just leave that at that. No, 25 mil thick. We won't bother to put the length. All right. Now we're gonna go to the. We keep going up, and then this now becomes the rafter. Rafter 150 mil by 50 mil. Keep going up now. Tongue and groove boards or close boarding. Call it close boarding. 150 mil by 25 mil thick. Right? All right. Let's continue. This is glass, glass buttons, 25 mil thick, 25 by 50 mil. All right. I think we got everything there. Now what I'm going to do is I'm going to grab this and scale this up. I don't like how that seems to be a bit too small. Right, so I'm just going to scale it up. Not any specific scale. And I'm just going to bring some of these notes away from each other so they can breathe. I'm going to hatch that. That there is that. There's that hatch. This now is some timber. User. Once I have finished this now, we can just check over, have a review of this exam, and that should be it. But yeah, I need to label this detail. Very important at the end, you need to label your details. Because this isn't just an eave detail, this is a closed eave detail, right? Okay. Let's move this now. Can this fit into here? No. So say this were an exam. I would just duplicate this, copy this out. Good. Now I'm inserting the title, calling this the end. Explode this. So this will be called a closed Eve detail. What scale am I supposed to draw this to? Marks will be awarded for the following: orthographic section, detail, proportionate sketch, line work, line type, line weight. No scale. So when it's a case like that, I would put here scale, not to scale, not the scale. All right. Increase this. All right. Bring this closer. Remove that. Bring everything closer. Save. And let us now have a final review of our exam. Oops, before I go, I need to insert my hurricane strap. So just put up a rectangle here. Like that. Put some circles in between. Yeah, these are the hurricane straps. We put back the pin out for there. Yep, pin out there. And how am I going to insert the hurricane strap now? Lines cross each other. So that's where we'll put the hurricane strap. So let's start here with what? So we did question one. Question one asks us to draw a site plan. And we produce that site plan. Let's have a look. This is a site plan. Site plan scale to 100, showing the location of the building, boundary lines, proposed building in accordance with given setbacks, sewer pipes in relation to proposed building, septic tanks and soakaway, direction of flow for drainage of surface water, eve line, north symbol, identify streets and driveway, setbacks for the front and the back, and the boundary lines all around the property. That has been done here. Print a suitable title and scale used. That has been done here. We can now move on to question two. What does question two ask of us? Sketch an orthographic sectional detail of a closed eave. Clearly label the following components. So what have we done here? We've sketched the orthographic sectional detail of the closed eave. We have labeled the block wall. We've also stated the size. We have labeled the rafters. We have labeled the lafts. We have labeled the fascia board. And we have labeled the hurricane strap. All right. And then we have also placed a label over the entire drawing called closed eave detail. And it's not drawn to scale. So we have answered both questions for this exam, which brings us to the end of this examination. You say here, end of test. If you are finished before the time is called, check your work on this test. So this test again is a 2 hour. Let's look back there, 2 hours and 40 minutes. And we are well within our 2 hours and 40 minutes. So this is when I would encourage students to go back and check over your work. Check over your work first before you actually submit your examination. Now, this brings us to the end of this session. I hope everyone enjoyed it, and most of all, I hope you learned something from this session. If you're having difficulties, you go back over this, review this, go in slow motion, play it back until it makes sense to you. Okay? Lastly, I would encourage everyone to practice. CXC is just around the corner. We don't know what's going to come on the exam paper. So practice this. I also have a past paper, another past paper on my channel. It's the 2012 past paper. On that one, I focus on section drawing and elevation drawing. Today, we focus on site plan drawing and eave detail drawing. So you should practice reviewing, you should consider reviewing these exam videos so as to sharpen your skills and better your skills and fill in the gaps that you have. As usual, I would encourage people to share this information around, like and subscribe to the channel. I am out. Thank you.